So welcome to this Docker Beyond F5 Part 2 session. So who attended my first part?
Oh, wow.
Okay.
Thanks.
Thank you. No pressure. So this is the deep dive that I promised. So we will go into a number of things. So maybe Alex, you can tell after we did not introduce ourselves.
Yeah, skip it.
Go to today.
Well, I think our story today is about the pain that we experienced when we started working with Docker. That was 2 years ago, I guess, and then last year, and now with the new tooling. It takes some effort to get used to what is there, what is happening, and it's all fine as long as F5 puts you in debug mode and you start doing your things like you're used to, but then you press F5 and it just crashes and burns. That happens. And then you start to find out that there's a lot of things going on under the covers, and understanding what is happening there will make you troubleshoot that far easier than not knowing what is happening and referring to magic and other things. So we're taking away the covers, we're revealing the tricks of Visual Studio and the Docker tooling to help you get started and to really understand how you build your .NET applications using Visual Studio and Docker.
So which does not mean that you cannot use the Visual Studio F5 tooling. It's not that it's bad.
No.
Only it's very good to know what happens behind the scenes, because otherwise sometimes you really get lost in why it works or it doesn't work in most cases. So maybe we should talk a little bit about containers. So I showed this picture in my session, and I showed the simplified version of things. So I showed on okay, we have containers and virtual machines, and they differ from each other. And in my previous session, because it was the higher concept, it was basically about there is no operating system on that container, which makes it faster and easier to use. But there is more going on if we look at the detailed pictures. So maybe you can explain.
Yeah, so stop thinking about virtual machines. We'll get back to virtual machines in the next slide, but that's a special case. So containers is nothing related to virtual machines, and even though a lot of people, including myself, say just think of virtual machines, don't do it, because if you run your containerized applications consisting of a set of binaries and the dependencies, the libraries that go with it, you're actually leasing or using the underlying host operating system. It has a kernel, and the kernel is what is used from your container. So your container with the libraries in it, leveraging the underlying kernel is enough to make your application run. It doesn't need the entire operating system, just the kernel. And a container is isolated from each of the other containers that are there. So they are not allowed to look into each other's contents or what they are doing. So they're isolated, and that's a good thing, because they don't need to know anything, and their world lives inside of that container. And they even think they can write to the file system, but actually they don't write to the file system, to the C drive or the root or whatever directory they think they're writing to. It doesn't actually happen. It's all taken care of by the host operating system. So isolation, you start those containers from images, which is sort of a blueprint with all of the files and settings that are required for the kernel to know what to do. The binaries that you use are targeted for the underlying host, the kernel that you're using. And that's important. So if you build a container with Linux binaries, then you need to run on a Linux system. But it doesn't, like René just said, it doesn't require an operating system. So they're very fast to spin up because the kernel is already running underneath. And all the mapping, the container stuff, is part of the operating system. On Windows, there was the notion of container support as well, but Microsoft has done a lot of work to make that more resemble the way that the Linux world does it. So they are now also able to run their applications from a Windows Server container. This only works, this direct running on the kernel only works on Windows Server, not on your Windows 10 development machine that you might use. So it's similar, but it's a Windows Server container. Okay, so the question is, what about Windows Server 2012? No container support as far as I know. you need 2016. Then you have the hypervisor, which is the virtual machine abstraction layer. So what Microsoft does is they build more isolation into the containers. So they spin up a small virtual machine with a highly optimized Windows operating system, and there they spin up your container instances, which makes it far more isolated, the ultimate isolation that you can get on Windows. And they're called Hyper-V Windows Container, and they're working on Hyper-V Linux containers as well. So this is where you can actually run a different set of containers, Linux, even though your underlying kernel is Windows. But it's by means of virtualization and isolation. All right, Docker engine does all the management, so Docker comes in as a standard to work with those container instances, the images, starting them, stopping them, whether it's Windows or Linux. And it's unified tooling built by the company that's called Docker, and Microsoft has a tight collaboration to make their operating system adopt Docker. So,
I think, in terms of this, I got a question after my previous session. Like, you told us that you cannot run Linux on Windows, but you are doing that by the command line. So that's actually not true. I understand where the question comes from. So maybe we should just show quickly why we can run Linux containers while on Windows on the eye. So, or who doesn't know that, why it works? Or who knows it? Let me, okay, so lots of people who don't. So I think it's fair to do a very quick demo. So if you install the Docker on Windows tooling that you can download from the Docker site, you install the toolset, and when you first start it and you choose to run containers on Linux, what it actually does in the background, it starts up a virtual machine in your Hyper-V. So Hyper-V on your system must be enabled, otherwise you cannot do it. So it starts up a small virtual machine, the Moby Linux VM, which is very, very tiny Linux operating system. And then the Docker tooling on your Windows machine makes sure that all the commands that you type in your command line are actually executed on that virtual machine you just have running here. So we are not running Linux containers on Windows, but we are running Linux containers on this small operating system, and it seems with command line tooling that it's running on our machines. So that's good to know. It's nothing special happening here. It's just a virtual machine that's in between.
Yeah, and the Moby Linux refers to the whale, Moby. And it's their operating system. You can install additional machines, similar things to the Linux Moby Linux VM. And if you boot them, you can connect to them, and you actually see all this booting of the operating system coming by, and also ASCII art Moby is coming by. The Hyper-V Linux and Hyper-V Windows are hidden from this dialog. So if you start Hyper-V containers, which is Windows only, then you will actually not see them here in Hyper-V Manager because it's irrelevant. It's not intended to be a virtual machine as such.
Yep. So back to this one.
Yeah. This is the new developer workflow. Who's a developer here? Good. I think you covered a lot of these things in your previous session. It's actually about this inner loop where you work with Visual Studio, you build your code, you run it locally using containers, you see if it works, you work with the images that arise from it, and once you're done, you will commit your code to source control, can be a Git repo or TFVC, and it goes through your CI/CD pipeline. But besides just building it, your pipeline will also build the container images, the blueprints with all the binaries that need to be packaged inside of the container image, so it can be given to a Docker host, which can just start up that particular container. It's done through the means of a container registry, and the registry is this storage place where you can upload your container images, and the right side, the cluster that you will probably use in production, can just pull those images from the registry. So it's sort of like NuGet packages, pushing them to the feed and pulling them when you need them, but with containers from your development machine to your environments, also your production environment. Oh, another demo.
Okay?
Yeah.
So, going to our favorite tool, what should it be? The command line? Yeah, for now. So just to show you, with the command docker ps, we can show you all the containers that are running currently on the system. So there's nothing running yet. And just to make sure, also for our demos, because otherwise some port mappings are in use and stuff, just to make sure we also don't have any stopped containers that have any port mappings in use. So our system is clean, you can say that. So when we go to Visual Studio, we can see something happening here. So we have a project that is an application with a front end, a website front end, and we have a web API, and they use each other. So the web front end speaks to the API to get some high scores or something. What we already did, and I showed you how to do that in my previous session, but we already did add Docker support on the project. So the F5 experience, as you might call it, right-click on the project, add Docker support, and Visual Studio takes care of creating a new kind of project template, so a Docker Compose project, which contains Docker Compose files, and it creates Docker files within the projects themselves. These Docker files are the blueprint of how the container images are created when we press F5. So the layers that you see here, so the from an ASP.NET Core base container image, we will add some sources. We go to a work there, we expose port 80 because it's a web server that we want to run. We copy some source, some precompiled assemblies into that container, and once we start this container, then we will run the command .NET gaming web app.dll. So it will start our .NET application. So let's make sure that we are in the debug mode. So if we press this one here, the play button, the F5 experience, Docker Compose is started with the Docker Compose up command. So it will create containers from our application, so it will publish them into a container, and those containers are started. We will explain Docker Compose later on in the session, so we will not go too far now. But now it starts not only my web front-end application, but also the API application, and both at the same time. So the Docker Compose takes care of that, of the composition of the containers. So now we have something that's not running.
No.
That's because we are moving to the wrong
endpoint, and we'll fix that. Well, what we didn't say is we'll make a lot of things go bad, because we said the pain that we experience, we want to share that with you. So we'll show you stuff that won't work. For example, the URL that just was bad, it's hidden somewhere. It's API/values. If you do a file or a new project, web API project, you know, API/values, you must have seen it, and it's still there. It's hard to get rid of, and if you do a search, you can't find it. So where does it come from? We'll fix that.
Exactly. And we also have this web application which is running on, what was it, Alex? 8080. Which is hopefully the high score list.
Yep.
And if we add something to this,
that's my
application.
Xbox 360
Alex.
nickname. Yeah, Alex360.
He insisted to use this one, and he wanted 42 points. Don't ask me why. So it's 200. So if we now refresh this, we have a high score. And that seems pretty basic and pretty trivial, but there are two containers that are running isolated on my host system. They cannot see each other. But Docker Compose, it it made sure that they can see each other. So they know where to find each other, they can talk to each other, and they are running in isolated processes.
Yeah.
So that is nice.
You can show them running on Docker PS.
Sorry?
Docker PS.
Yeah, we can do that. So when we now do Docker PS, we have indeed a container running. So the gaming web app, dev, that's the front end of the application. The web API, that's the API. And there is another one running. The SQL Server Linux. So there's also, magically, for now, we should not say that, but for now, a SQL Server started. Wow, that's good.
Because, I mean, to me it was kind of a revelation that usually if you go into a new project and they say, okay, just download the source code and you need to install, and you get a list of things you need to install, usually including SQL Server on your box. So you install SQL Server Express or LocalDB or whatever you need to get things running. But here we just use a container to run SQL Server. So you can pick a clean system, download the source code, press F5, and because we included the data layer with the database server in the composition, we also get a Linux-hosted SQL Server. And it's using Entity Framework to communicate with that thing. All right.
Okay. And we wanted to fix that strange stuff, and I already forgot where it was. So.
Right-click on Docker Compose project.
Oh, there it was.
Properties. And then it's the new dialog. And you can see that there's some markers there, service port, because when the composition starts, it will do these things of determining service ports, and it will fill that in, and the /API values, we can just get rid of it so we don't bother with it anymore. But that's one of those hidden places.
I will make it Swagger for now.
Yep. And the Swagger support is what we added to the project, which might be handy for your web APIs as well. So you have a graphical user interface, that's the Swagger UI, and Swagger also takes care of providing a Swagger metadata for your web API, because it's a REST-based API. It doesn't have a WSDL file like SOAP services does.
Exactly. So I think it's now a good time to just go back to this Docker file and spend a little bit of time on how this layering works, because we have all these layers built on top of each other, and I think we have a good slide on that maybe explains it a bit better. Is it still running somewhere? Yep, it is. So maybe we should stand a little bit here. Yeah. Okay.
So building your container image, the Docker file, all it does is provide a set of instructions, and for .NET Core applications it's usually the one you saw in some slight variations. But what you want to do is put all your binaries from your application and all their dependencies into the container image. So you need .NET Core, the .NET Core runtime, the .NET Core effects, which is the base class libraries. And we have the build output, the debug output of our project, the gaming web app DLL. It has a program database and some bunch of JSON files that indicate dependencies and some runtime configuration. Those 5 files are around 4 megabytes, and they need to go into the container image as well. The container image, there's 2 flavors of it. So the top one is a container image that you would build if you would run on Windows. On a Windows kernel, you need a Windows container image. It takes a dependency on the fact that you are running on Windows, and you will put the binaries in there, so the 5 files, and you will pick the Windows runtime for core CLR. And that's all done by the compiler and in another way, which we'll see in a moment. Underneath, the Linux container image is able to act as a blueprint to start a container instance on Linux. It has the same binary, so the same 5 files. That's .NET Core, cross-platform compatibility, but you need a different runtime. So the things underneath the application change a little bit. And so that's actually where this is going with building your files. The first line is the from, and that says, okay, we'll take a starting point, a base image. We won't start from a clean machine. Well, actually we do, but we just want to step in a little bit later, and things have been taken care of. So in that case, the ASP.NET Core 1.1 was chosen. It can be Core 2.0. But that image is actually taking a dependency on other layers. So you can be a Windows or Linux distribution. Debian is the one that we pick for this case. It will add, so Microsoft has already built an image that adds runtime dependencies on the Debian stretch image. an operating system, then there's the runtime for .NET Core 2.0 is also added to it. Then the ASP.NET Core files are added to it, and that's where we as application developers say, okay, that's where we want to step in and add our 4 megabytes, the 5 files that we saw, and put that in. So our application is actually leveraging existing layers that already have been downloaded on your system for other ASP.NET Core applications, and we just build a new layer like a delta, the change that has happened from the clean ASP.NET Core 2.0, and then we add our files. So it's very efficient, because if you need to download our application, it only needs to download the top layer if the other ones are already there because of another application.
Yep. So if we then go back to this demo, and we know a little bit about the layers, and we saw that Docker file that's built up of all those instructions that you can give on how to construct or build a new container image. What is the usual thing to do, and I showed it earlier as well, is to just go to your directory where everything is. And this is my, so I need to go to source, and then I go to my applications, and then let me see, then the gaming web app. So here is my Docker file, and then we would usually say to any other Docker file, Docker build, with a name that we give it, and let me see how we called it here. So TechDays 2017, and then we call it, for example, live demo, and we use the context of the current directory. So Docker searches for a Docker file in this current directory, and so this was the first thing that we tried, and then we get this. So and you will get that as well if you try it. So the copy failed, and so we thought, okay, so the object Docker publish, no such file or directory. And I thought, okay, well, there is no mention. How should we be able to get that directory? It's not there. So if we go back to that Docker file that we looked, we have this line of code there. And this is actually the trick. So this copy source and then that minus object Docker publish, it says that look for our directory object Docker publish if there is no source argument filled from the outside. So what we discovered is that if we run in Visual Studio by pressing F5, Visual Studio will fill an environment variable, or it will actually throw an argument into that file pointing to a place on our file system where the published files are. So Visual Studio knows where they are, and it just provides an argument to the Docker file so it runs nicely. But if you don't have that, so if you run on the command line, you don't have that directory up front, and your Docker build will crash. So what we can do is we can do multiple things, but I think the best thing that we can do is just to say, let's say we do a .NET restore. And after that we do a .NET publish -O, and we are not going to publish to that same directory because we are now in debug mode, so let's not do that, and we are going to publish to bin/debug/publish. So it's not the thing that is in the Docker file. So then we are publishing, compiling.
You're spending too much time in Linux nowadays. You use the other slashes. Did you see it? No, you
No. Is it not working?
It's good, but it's
good.
we didn't use backslashes.
Sorry. Oh, yeah.
Just saying.
Yeah.
That's okay.
Oh well. Okay. I don't mind. So, when I'm doing this, it will still fill, of course, because it doesn't find a directory. So what we need to do is we need to add a build argument. So let me put that here, build arg. And then I can say the source, that's the argument that is defined in that file here. So it's called argument source. So I can give an argument source. Source is pointing to the, what was it, bin/debug/publish. So now it will not run. So that's the second thing. So We figured out why it didn't build, because we don't have the files. And now we know how to get the files, and we will put them in the same argument, and it still doesn't build. That took me 20 seconds. No, of course not. So it's not that hard once you know it, because if you look at this Docker file and you expand it, there is this file called .dockerignore. And this file, dockerignore, says, look, you can just ignore everything except that object docker publish directory. So, if we add the bin /* and we try it again, it will build a container because it will pick it up. So there are those hidden things that you are not certain of that they even exist, that will make your life miserable at the time. So I think going back to the slides. Summarized?
Yeah, summarized. So this is what we just did. Visual Studio does it a little bit differently. So it will actually, once it builds your application, it will do the OBJ, debug or release, whichever one you picked, and it will publish everything. So that's your 5 files and the other things that are needed, your dependencies. It will publish them in the publish folder for a release mode. And it seems like this weird thing, because we did it from bin debug and then the publish folder, so why can't Microsoft do the same? And it has to do with a certain limitation that exists now in the CS proj files. Your project file indicates what the target is, and so your application is actually findable under the target framework moniker, which is a fancy word for Netcore app 1.1 or 2.0, whichever one you have. That's where it ends up in, but it cannot be predicted from the CS proj file. They're working on it, so they try to build in the support that if you look at the project file, you can actually predict what the folder underneath debug or release will be called. And now they just need to copy it to a known place, which is object docker empty or publish, and that's where you find it under the publish. So it's a workaround for now.
Yeah.
It might go away. And then the copy with the source, if you can't find it, fall back to obj docker publish, will probably also disappear. So that's how we build your image. You will find, depending on your Visual Studio, you will find a special Docker build source thing or generated Docker compose files. We'll get back to that later.
I think that we have to speed up then.
Yep.
Okay, so next thing, debugging container instances. So back to the Visual Studio. So we are here. I just disabled all the breakpoints, so let me just enable them again. If we run Docker, hopefully it doesn't have anything in use. So what you will see in a moment is that for the developer experience within Visual Studio, Microsoft did a great job, because you just add Docker, you can add breakpoints, and you can see that we can just debug through our containers, jumping from container to container, just like you are developing stuff on your local system. So that is great. So I'm now hitting a breakpoint.
Which is remarkable, because we're running in an isolated container, and still Visual Studio is able to jump into the process running on Linux and start debugging from your Visual Studio source code.
And the Swagger UI started up, and here is the container. So we can maybe let me just refresh. Then I will probably hit the breakpoint again. So here is the web API of the front end.
Home controller.
Home controller, and then we jump through, and then we will hit breakpoint in the API. So we will just jump through.
Can you maybe tell how Visual Studio does that?
Yeah.
Yes, that
Yes.
we will do.
We will do
just
that.
1 or 2 minutes, then we'll get there.
So in order to understand that, the first step is to know how does Visual Studio even know how to find the files on my local system? Because one of the fancy demos, I might call it, that Microsoft always shows is we are running in a container, we can change something on our file system, and then we hit refresh in the browser, and then it works. And That's strange, isn't it? So let me just do that demo because I can. So
And the
here we
remarkable
are.
thing here is that the container images, they're frozen. They're non-changeable. So whenever you have a container image, what is inside there cannot change anymore. So nobody can use the image and pollute it or make changes inside of it. It's the same every time over and over again. So that's really good for testing, for stability, for spinning it up in a lot of places, in a cluster, for example. But how can you change something that is copied into the container image?
So I just removed some comments from my HTML file, and when I now hit refresh, magically this image appears, but the container is immutable.
Yeah.
So that is maybe a bit strange. So to understand that, we should maybe just run in a just new separate container, or we can just
use the one that is running.
Use the one that is running. So if we find the one that is running, docker ps, so we go into the gaming web app, so that's container 828, so we can just jump into that one.
And while you type it, you see the container IDs that are there, the long weird numbers. They're even longer. This is just the abbreviated one. You can refer to your containers using that number, or to your images using such a number. But it's a long thing to type or to copy paste. You can also pick the first number, and if it's unique, it will be enough. So 3 is usually enough, but sometimes even 1 is enough. So 8 would do the trick as well. So you just type enough, and if it says there's more than 1, then it won't execute.
So if we look in this container and I do a directory listing, there is all the files that are needed for running the web application. And when I am in Visual Studio and I just say add a new item, and let me just add a text file, for example, type something and save that one, and I'm in the container and I do my directory listing again, my text file appears. And that is, I think, the magic that happens, because it's actually not the files within the container, but it is a volume mapping. So we can see the files on the host. That's why we can change it, and it directly changes in the container. And that's also why debugging works. And there we have a slide.
Yeah.
I think.
So what they actually do is the host allows the container to have a loophole outside onto your file system, so your source folder. So the container can actually reach it. It thinks it's doing local stuff with the /app, as you just saw, but actually that's tunneled outside of the container into the host file system on our C drive. It is a security breach, but the host has given the permission. And this is your machine, your host, so you've done it. Yeah? You're the security breach. Sorry? Yes.
And then your Hyper-V also has.
Yeah.
Yes. So it's a two-way thing. The container is instructed to have this /app as a volume mapping name, and the host provides the details of where the other end of the tunnel goes to. So we might actually do a Docker inspect.
Yeah, we can.
Oh, yeah.
And I would also like to show you that the shared drive here.
Yes. This is an important checkbox because you need to give your host, security stuff, permission to share drives to your containers, because potentially they could reach anywhere on your file system. And if you pick the wrong place, then if you have a rogue container, there's an image you got from somebody and you start it and it starts doing, you might be in trouble. But this is just the mapping on your user data your user folder, so it can reach your files. If you do a Docker inspect, you need to drop out of this one and do the Docker inspect 8. Yep. What you will see a bit to the top, there, volumes, bit down. Yep,
Yep.
there. There you see 4 volumes that are defined from within the container, 4 maps that will be there. And they will be given from the host, and so the top one, the /app, is going to your source folder. The remote debugger is going somewhere else, and that's in the slides.
Yeah. and we have all kinds of variables here as well. So in terms of time, I think that we should maybe a bit hurry up.
We can skip this one, but
go to Docker Compose.
yeah.
But you wanted to talk about more about?
No, just that in the slides, and you'll get the slides, but there's the entire list of all the mappings that are there. Yep. Oh, wow, good. Yes, this is only for local stuff, and which is our next topic, so thanks for that again.
Okay.
Yeah, so we just go to...
We go to
the demo.
The demo, yeah. So, let's stop this one. So, what we skipped until now is this project here. So, we have that Docker Compose project. So when you add Docker support, it will create Docker Compose files for all the projects within your current solution. So for now, we have 2 applications, and Docker Compose is a file that basically holds the configurations for spinning up a composition of containers. And as you can see, there are the services. It's a YAML file. There is a service called Leaderboard Web API, and we will call it, once it's built, the container image, we will call it Leaderboard Web API. It will be built from this directory, from the Docker file, and the same goes for the gaming web app, and there is a dependency between the two. When we hit run, then it will pick up this file, and it will start running the containers. Maybe we should just dive into the override directly. So on your local development PC, there is also the notion of a docker.override.yaml, the Docker Compose. And as you can see, there are lots of extra variables that are defined in this file. And environment variables, connection string, dependencies, port mappings, networks, and we even add a whole new container that we want to start within this compose file. Because you can see it like, this has a Docker Compose file, wants to start 2 applications, but on my development PC, I want to change and tweak settings. I want to change the connection string. I don't want to use a SQL Server somewhere on Azure, but I want to use it locally on my machine. So there is a base file, Docker Compose, and you can add layers on top of that. Should we open the slide?
Yeah, sure.
Here it is.
So this is what we just saw, the Docker Compose structure. It defines services, networks, and volumes. That's the most important parts. So it allows you to define everything that you need for your application landscape once your container instances are running as a whole, working together to build this application. The layering is what we discussed. So you keep your bottom one as clean as possible, the minimal information that doesn't change regardless of where you're running. So we chose to run SQL Server Linux locally, so that should not be in there, but should be in the override that we just saw. So the override will do additional dependencies, the port mappings, environment variables, because they might change. And it's just, you can layer as much as you want on top of it, and that builds your composition. And Visual Studio uses this. So it has the Docker Compose, the override, and then it has the 2 special ones that are in the red box, a generated debug and release overrides that are added on top of that again. So if we're talking to the question of the gentleman over there, so how do you want to distinguish between local things for debugging and for release? This is where the distinction is made. Shall we open them up?
Yeah, why not?
Yeah. So you find them in your in the root of your solution. So if you go there,
I don't know. I have to just
right-click, open for.
Yeah, we have to do it in Explorer, I think.
OBJ, Docker.
So
and there we have them. Yeah.
So let's just both.
So this is the debug one, as far as I can tell.
Yeah.
Because this is the one where the volume mappings that are there are defined. So this is the actual locations that the other end of the tunnel goes to. For the 4 that were defined in the from the container's perspective. It has the environment variable, so it does use polling file watcher, which is why we can change files. Just a second. And other things like the NuGet fallback package folder, things for debugging. And if you go to the release one, you'll see that it's cleaner. It only has a volume for the remote debugger, and it doesn't do all the volume mappings to your source code, because this will actually use your binaries, your DLL files, instead of the source code.
Exactly. And what is also good to mention is that the development, the debugging, so the override is something about your environment. I'm going to build this for development, acceptance, production. So there you can use your overrides, changing the connection strings, changing the ports, etc. And then you have your release mode or debug mode, in which you can add other stuff on top of that. So it's layer on layer on layer that you do. And in the debug image, you can see that even the name of the container image that we are creating will change. So in the compose, we say, we create an image that's called TechDays 2017/gaming web app. That is the name that we will publish to our registry. But in the development composition, so in the override, we'll say, okay, we just call it differently, so that we won't mix them and match them.
Yep. So we have a separate debug, because this one, the gaming web app with the tag dev, you can't run it. If you just do docker run and name that image, it will say, I can't do it because all the mappings need to be there to the volumes, and it doesn't have anything inside. It's just an empty thing looking outside for development and debug purposes.
So I think that it is very nice to show that if we now just open in, oh, why did it close? I don't know. Okay, well, doesn't matter. So let's go here. So the nice thing is of those compose files that Microsoft uses them themselves as well for doing stuff on the command line. So if you have this Docker compose and we are in the right directory, so we can say Docker compose build, for example, it will create us an application, a composition of containers, hopefully. So it will look at it and it will say, okay, we are going to build and we are going to publish. So we have the same error that we got when I did Docker build on a single container, but the compose has the same issue. So how can we build this application from, for example, a build pipeline? Because maybe we don't have the .NET framework installed there.
Definitely not Visual Studio.
Definitely not Visual Studio. So we need a way to do that. And I think it's it took us a while to figure it out, but it's actually pretty brilliant, because Microsoft uses its own Docker Compose technology to build container images without having anything installed on your host system. So there is this file that's called Docker Compose CI build.yaml. And when you look at that, it defines a container, and with volume mapping, it maps your sources from your local system into that container, and it will execute the .NET restore and publish commands. So this container is building our application, and the output will end up again on our host because of that volume mapping.
Think of it as a build server inside of a container.
So when we do Docker Compose and then -f, and we point to that file and we say up, because we have to start it, it creates that container, that CI container, maps my sources into that container. That container will build, publish files to our local system to the right directory. So that object Docker publish directory is now populated by this container, by running the commands in this container. So
it's restoring all the NuGet packages, just getting them in fresh, because the build container is clean every time, so this will happen every time. but you'll have a reproducible way of creating your binaries. And then we will just do all the compiler stuff, but running from a Linux container. And then it pushes it out to the obj docker publish, the last yellow line in the output. And now all of a sudden it works, because the correct folder is there. So if the Docker Compose build just looks at all your services, picks up the build lines, sees which things it should build, and creates the images.
We actually are running out of time. But I think the thing that happens here is we are starting this Docker Compose and an override. And the override is starting up some SQL server, but we are using the production images, and they don't know our development production server. So if we start this with our Docker Compose base file, minus F,
yep.
Sorry, Docker Compose base file, and minus F again for the Docker Compose Azure, production.
Yep.
That is a database connection pointing to a database somewhere in Azure, and we say up. Then it will start a container, and the connection string is overridden in that production file pointing to a database on Azure, and we are running on 8089, I think, so that is the high score list from a production database by the Docker Compose file. So that brings us to an end, I think. So let's pull up that. Oh, okay, there it is.
We did all that.
Deploying to a registry. So we did not run in a cluster, but that CI build, that CI YAML file that I pointed out, that's the one that you use in your build pipeline, and that produces images that you can push to your registry.
And it's actually easy to create them from VSTS now, because if you pick a template for your pipeline and you pick the one ASP.NET with containers, you will get all the Docker Compose tasks in your pipeline that are ready, set, and go to make this easy to do.
So, that brings us to an end. If you have any questions, which I can imagine.
Yeah, we have one over there that was paused.
So let's first round up so that people can go to other sessions. Then come over here and we will answer the questions. So I think that we are at the booth. There are some magazines which all this stuff is in as well. So you can grab those. Thank you for bearing with us because we are running late. We started late and now we are over time as well. So sorry for that. I hope you enjoyed it. Thank you very much and next time.
Thank you.